In this video, we're going to be looking at solving integration problems using partial fractions. When you have an integration problem that looks like this, and this, and this, and this, the best way to solve these problems is by using partial fractions method. And now, before we go into solving these problems, we have to first understand the rules of partial fractions. From the term partial fractions, we know that we are dealing with fractions, right? And fractions consist of the numerator and the denominator. Okay, so the first rule is that the degree of the numerator must be lower than the degree of the denominator. So what does this mean? If we have an integral, say x over x squared minus 3x plus 2 dx, the highest power here is 1, right? So the degree of the numerator is 1. The highest power here is 2, so the degree of the denominator is 2. So we can say from here that the degree of the numerator is lower than that of the denominator. And so we can use partial fractions to solve this problem, right? And that takes us to our next rule, which is to simplify and factorize if possible. For this particular question right here, we can factorize the denominator to have it written as integral x over x minus 1, x minus 2, right? And what if we have a question like, say, integral x squared minus x divided by x cubed minus x squared plus x minus 1, right? What if we have a question like this? We can simplify. So whenever you're given a question that looks kind of bulky or too voluminous in code, you can easily try to simplify first. So we're going to check if it can be simplified or factorized, right? So we can factorize the numerator, right? To have x into x minus 1 divided by the denominator. When we factorize this, we're going to have x minus 1, right? X squared plus 1. Okay, and so this cancels out and we are left with the integral of x over x squared plus 1 dx. So we have easily simplified to this point. Now let's move on to the third rule. We're still going to get into solving problems, but these rules are just to lay a foundation, when solving partial fractions. Now the next set of rules will show us how we express our partial fractions. And these expressions are based on the factors of the denominator. So using the example integral x over x squared minus 3x plus 2 dx, rewriting this, simplifying by factorizing the denominator, we have x over x minus 1, x minus 2, right? Now these are the factors of what? X squared minus 3x plus 2. X minus 1 is a factor, x minus 2 is another factor, and these factors are called linear factors, alright? And they are linear factors because the degree is 1. The degree of x minus 1 is 1, the degree of x minus 2 is 1, alright? So for a linear factor, which is our rule 3, for a linear factor in the form ax plus b, right? The expression of the partial fraction is given by a constant, let's call the constant a, divided by the factor ax plus b. So in this case, to express the integral of x over x minus 1, x minus 2 in the form of its partial fractions, we write that as a constant, right? A constant a divided by the first factor, which is x minus 1, right? Following this pattern, plus another constant b divided by the next factor, which is x minus 2. Very, very simple. And that's how we go about that. Now, the fourth rule. Now, for the fourth rule, we are still dealing with linear factors. But now, we are considering a different case for the square. For the square of a linear factor in the form ax plus b all squared. So how do we express this in its partial fraction, in form of partial fraction? We write that as a constant a over ax plus b, right, plus another constant b divided by ax plus b all squared. Now there is a pattern I'd like to bring out to help you remember, right, these rules. But quickly, let's look at the fifth rule. The fifth rule is very simple as well. For the cube, right, of a linear factor, right, we've done a linear factor, the square of a linear factor. Now, for the cube of a linear factor in the form ax plus b cubed, we express the partial fractions as a over ax plus b over ax plus b all squared plus c over ax plus b cubed. So the pattern there is that for a linear factor, we just express the linear factor, right, once. And then for the squared, we express the linear factor, right, and then we express the squared, right. And for the cubed, we express the linear factor, we express the squared, and then we express the cubed. When we get into solving problems, I believe you would understand much better. And the final rule here is for a quadratic factor in the form ax squared plus bx, right, plus c. In this case, we include something new to the numerator, which is ax, and then we add another constant to it, right? This is a term, a single term, and then divide by the quadratic factor, which is ax squared plus bx plus c. Okay, so if we have a factor, say x squared plus 2, right? If we want to express this in the in partial fractions for the quadratic, that is going to be ax plus b divided by x squared plus 2. Now quickly, let's get into solving problems. Alright, we're going to break down these problems step by step. Alright, so our very first question is to find the integral of x plus 1 divided by x squared minus 3x plus 2 dx. Okay, so we have a factorizable denominator, so we're going to factorize this, and get the factors. Okay, so this is the same as the integral of x plus 1 divided by
The factors of this quadratic expression are minus x and minus 2x. When we add minus x and minus 2x, we get minus 3x. And when we multiply minus x and minus 2x, we have 2x squared. Okay, so this becomes x squared minus x minus 2x plus 2, right? dx. And this becomes the integral of x plus 1 divided by x into x minus 1 minus 2 into x minus 1. Okay, minus 2 multiplied by x gives us minus 2x, minus 2 multiplied by minus 1 gives us plus 2. Alright, so finally we can say that simplifying this expression now gives us the integral of x plus 1 divided by x minus 2 x minus 1 dx. Okay, at this point the next thing to do is to break our expression into partial fractions. And following the rules of partial fractions, as we have stated earlier, this becomes a over, the integral of a over first factor here, which is x minus 2, plus another constant b over the next factor here, which is x minus 1 dx. So at this point, the next thing we want to find are the values of a and b. So the purpose of breaking down this integral into partial fractions is to make our evaluation or the finding of the integral much more easier. So as we have broken this down into partial fractions, by the time we get the values of a and b, we can easily integrate and get our answer. Alright, so how do we get a and b? Okay, so we have this to be equal to the integral of x plus 1 over x minus 2 x minus 1 dx, and that is equal to the integral of, let's find the LCM, so we multiply x minus 2 and x minus 1, okay, and then x minus 2 x minus 1 divided by x minus 2, we're left with x minus 1, and then we multiply that by a, so we have a into x minus 1 plus x minus 2 x minus 1 divided by x minus 1, we're left with x minus 2, and then we multiply that by b, and so we have b into x minus 2, right, dx. Okay, so at this point, comparing both sides, we can say that x plus 1 is equivalent to a into x minus 1 plus b into x minus 2. So at this point, we can easily find a and b. If we make x to be equal to 1, this becomes 1 minus 1 and a becomes 0. And if we make x to be equal to 2, this becomes 2 minus 2, and b becomes 0. So let's make let x equals to 1. So this becomes 1 plus 1 equal to a into 1 minus 1 plus b into 1 minus 2. So this becomes 1 minus 1, 0. So 2 will come right here. 2 equals to b into 1 minus 2 gives us minus 1. Alright, so b equals to minus 2. And if we let x equal to 2, we're going to have, substituting 2 into the equation, we're going to have 2 plus 1 equals to a into bracket 2 minus 1 plus b into bracket 2 minus 2, and this becomes 3 equals to, this becomes 0, right? And this becomes a into 2 minus 1 is 1, so a equals to 3. So we got a and we got b. Okay, so now we're going to substitute it back into this equation right here. So at this point, we have the integral of x plus 1 over x minus 2 x minus 1 dx to be equal to the integral of 3, right? 3 over x minus 2. Now we have minus 2. So I'm just going to put it right here. Minus 2 over x minus 1 dx. Alright? So this goes together, right? We can split the integral. So we have integral 3 over x minus 2 minus integral 2 over x minus 1. So this is with respect to x, with respect to x. And we can write this as 3 integral 1 over x minus 2 dx minus 2 integral 1 over x minus 1 dx. Now, to evaluate these integrals, the law is that when you differentiate the denominator and it gives you the numerator, the integral of the question is the lane of the denominator. So differentiating x minus 2 gives me 1, right, which is my numerator. So the integral of 1 over x minus 2 is going to be 3, right, this 3 out here, multiplied by the lane of the denominator, which is x minus 2. And same here, we have minus 2 multiplied by the lane of the denominator, x minus 1, and then finally plus c. Okay, to understand this better, you can check out my video on integration problems. I'm going to leave the link in the description below. I solved a lot of problems there starting from the scratch. Alright, so that's that. So let's go on to the next question. For our next question, we have to integrate x squared divided by x plus 1, x minus 1 squared. And so we're going to split this into partial fractions. And so from our rules, we have established that this is a linear factor, right? And this is the squared of a linear factor. And to split that into partial fractions, we're going to have a over x plus 1, right? We are done with this factor. And for the one that has the squared, we're going to have a constant b over x minus 1 first, and then another constant c over x minus 1 squared. Okay, if it's a factor which is cubed, alright, it is going to be x minus 1 first, then x minus 1 squared, then another constant, right, and then x minus 1 cubed, right? That is if it is cubed. So that's basically that. So at this point, we can proceed with our integration. And so we're going to have the integral of x squared over x plus 1, x minus 1 squared dx to be equal to, here we're going to have x plus 1, x minus 1 squared. And so we have x plus 1, x minus 1 squared divided by x plus 1, we are left with x minus 1 squared. So we have a multiplied by x minus 1 squared plus x plus 1, x minus 1 squared divided by x minus 1, we are left with b into x plus 1, x minus 1, and then plus c multiplied by x plus 1 dx. And so at this point, we can compare both sides and conclude that x squared is equivalent to a into x minus 1 squared plus b into x plus 1, x minus 1 plus c into x plus 1. Okay, now we can obtain the values of a, b, and c. Alright, so if we make x to be equal to 1, a becomes 0, right? And b also becomes 0, so we can obtain c. let x equals 1. So we have 1 squared, 1 equals to a into 1 minus 1 squared plus b into 1 plus 1 multiplied by 1 minus 1 plus c into 1 plus 1. And this becomes 1 equals to 0 plus 0 plus c into 2, right? 1 plus 1, 2. And so c equals to 1 over 2. Alright, so let's put it here. C equals to 1 over 2. Alright, so what else can we do? We can make x to be equal to minus 1. If we make x to be equal to minus 1, that means that this becomes 0. I think this will also become 0. So let x equals to minus 1. And we're going to have minus 1 squared. That gives us 1, right? And that is equal to a into minus 1 all squared plus b into minus 1 plus 1 into minus 1 plus c into minus 1 plus 1. So this becomes 1 equals to a into minus 1 is minus 2, right? Minus 2 squared, right? And this becomes 0, right? Minus 1 plus 1 is 0, minus 1 plus 1 is 0, so this also becomes 0. And so we can say that 1 equals to 4, right? Minus 2 squared is 4, so 4a. And so a equals to 1 over 4. So I'm writing here, a equals to 1 over 4. Alright, so at this point, there are two ways to find b. We can decide to substitute another random value of x. We can say let x equals to 2 and just, substitute 2. Since we already know a and c, we can also substitute a and c, right? But another faster way to go about that is to compare both sides. So we know that if we expand, x squared will be equal to a into, this gives us x squared minus 2x plus 1, right? Plus b into, this is difference of 2 squares, so x squared minus 1 plus c into x plus 1, right? So we know that when we open this, we're going to have ax squared, right? And on plus bx squared and on plus cx plus and on like that. So comparing both sides, we know that the coefficients of x squared are a and b, and on the left hand side the coefficient is 1. So we can conclude that 1 is equal to a plus b. Okay, and then we already know a to be 1 over 4. So that means that b equals to 1 minus a, which is equal to 1 minus 1 over 4, which is equal to 3 over 4. So we've gotten a, we've gotten c, and now we've gotten b to be 3 over 4. And then the next thing to do is to substitute into this equation. And so we're going to have this to be equal to the integral of 1 over 4 over x plus 1 plus 3 over 4 over x minus 1 plus 1 over 2 over x minus 1 squared dx. So we can split our integrals and bring out 1 over 4, 3 over 4, and 1 over 2. So we have 1 over 4 integral 1 over x plus 1, right, dx, plus 3 over 4 integral 1 over x minus 1 dx, plus 1 over 2 integral 1 over x minus 1 squared, right, dx. Okay, so we can easily integrate now, right? And so this becomes 1 over 4 ln x plus 1, right, plus 3 over 4
ln x minus 1 plus 1 over 2. Now, in order to integrate this, what we're going to do is to rewrite this as the integral of x minus 1 to the power minus 2. Alright, so to integrate this, we do two things. We differentiate and we integrate. We integrate the entire function as a single function, and then we divide by the derivative of the inner function, which is x minus 1. So when we integrate x minus 1 to the power minus 2 as just a single function, following the power rule, we have x minus 1 to the power minus 2 plus 1 divided by the new power, which is what, minus 2 plus 1. And then we now divide by differentiating the inner function. When we differentiate x minus 1, we have what? 1. Okay? So what are we going to have? We're going to have x minus 1 into brackets minus 1 divided by minus 1. Okay? So what we have here eventually is 1 over 2 into brackets minus x minus 1, right, to the power minus 1. So we can conclude that our final answer is 1 over 4 ln x plus 1 plus 3 over 4 ln x minus 1 minus 1 over 2 into 1 over x minus 1, right, bringing down x minus 1, okay, and then plus c. Okay, so this is it, very simple. For our next question, we have the integral of x squared plus 1 divided by x plus 2 cubed. Alright, so give this a try and let me know your answer in the comment section. I'm not going to be solving this for you, so this is a test for you to try and let me know your answer in the comment section. So if you solve this correctly, your answer should be ln x plus 2 minus 4 into 1 over x plus 2 minus 5 into 1 over 2 into x plus 2 squared plus c. Alright, so let's take a look at a question that has to do with a quadratic factor. Evaluate the integral of x squared over x minus 2 x squared plus 1. Okay, so far we've dealt with linear factors, the square of linear factors, and the cube of linear factors. But in this case, we have a quadratic factor. Alright, and so to expand this in its partial fraction form, we're going to start with the linear factor, which is a over x minus 2, right? And then plus, for the quadratic factor, we're going to have the constant b, and then x, which is what we're introducing to the numerator, and then plus another constant c, and then divided by the factor, which is x squared plus 1. Alright, very simple. Okay, and then this is going to be equal to, so we are still integrating with respect to x. So this is going to be x minus 2, x squared plus 1, right? And here we have a into x squared plus 1 plus bx plus c into x minus 2, right, dx. That is equal to integral x squared over x minus 2 x squared plus 1 dx. Okay, so comparing both sides, we can say that x squared is equivalent to a into x squared plus 1 plus bx plus c into x minus 2. Alright, let x equals to 2. So when we substitute 2 into the equation, we're going to have 2 squared, which is 4. Now we equal to a into 2 squared plus 1 plus bx plus c into 2 minus 2
And so this becomes 0, right? And then 4 equals to a into 2 squared, 4 plus 1. And so we can conclude that a equals to 4 over 5. Alright, I'm going to write it here. A equals to 4 over 5. Okay, so how do we get B and C? Let's try to compare. Okay, let's try to compare values. Compare the right hand side and the left hand side. So x squared is equal to ax squared plus a, right? Plus this is b x squared minus 2bx plus cx minus 2c, right? And so comparing the coefficients of x squared, we can see that 1 is equal to a plus b, right? And a is 4 over 5. So b equals to 1 minus a, and that is equal to 1 minus 4 over 5, and that is equal to 1 over 5. Okay, so I'm going to write it here. B is equal to 1 over 5. So now, how do we get C? How do we get C? We can make x equals to 0. Okay, let's make x equals to 0. So let x equals to 0. We're going to have 0 equals to a into 0 plus 1, right? Plus b into 0 plus c into 0 minus 2. And so 0 equals to a plus, right, 0 plus 1 is 1 times a is a, and b times 0 is 0, and c into minus 2. Okay, we've gotten a to be 4 over 5. So I have, if I take a to the other side, minus a equals to minus 2c. And so c equals to 4 over 5, right, divided by 2. Is that right? Yeah, that's it, right. So this is 4 over 5 times 1 over 2, and we have 2 over 5. So c equals to 2 over 5. So now we can say our answer is equal to the integral of 4 over 5 over x minus 2 plus 1 over 5x plus 2 over 5 divided by x squared plus 1 dx. So let's simplify this. Let me put it here. This is going to become 4 over 5 integral 1 over x minus 2 plus, I'm going to split the integrals now. The integral, I'm also going to split this fraction. Okay, so I'm going to have the integral of 1 over 5x, right, over x squared plus 1 dx plus the integral. Okay, so I have 2 over 5 now. 2 over 5 over x squared plus 1. So let me rewrite this. Bringing out 1 over 5, I have 1 over 5 integral x over x squared plus 1 dx. And rewriting this as well, I have 2 over 5 integral 1 over x squared plus 1 dx. Now we can easily integrate, right? And this becomes 4 over 5 ln x minus 2, right? Plus, now taking a look at this, how do we integrate this guy? Remember that when you differentiate the denominator and it gives you the numerator, the answer is the ln of the denominator. So
When I differentiate x squared plus 1, I'm going to have 2x. But in my numerator, I have x. So what can I do? I can manipulate. I can bring in something to make sure I have 2x in the numerator. So what I'm going to do is to multiply my numerator and denominator by 2. So I have multiplied by 2 over 2. Okay, 2 over 2 cancels out. So it is mathematically correct. Okay, and so I'm now going to have what? 2x. Okay, and multiplying this 2 by 5, I'm going to have 10. Alright, so instead of 1 over 5, now I have 2 over 10. Okay, and when I differentiate x squared plus 1, I'm going to have what? 2x. And so the answer to this integral will be 1 over 10 ln x squared plus 1. Alright, I hope you understand that. And then for this we have 2 over 5. The integral of 1 over x squared plus 1 is tan inverse of x and then plus c. And that is it. That is the answer to the question. Thank you very much for watching. If at this point you have not subscribed, please hit the subscribe button, hit the like button, and let me know if you have any questions in the comment section. Goodbye.